Good morning all, and here is coordinatometer for you, and let's measure your coordinate caliber. Here we go. We have 5 questions and 5 minutes for you. If root a plus root d equals root c plus root b, and both of this is gonna give me c plus b plus 2 root bc. And since we know AD and BC is equal, so that will give A plus D equals C plus B. Now we can square this expression. A square plus D square plus 2AD equals B square plus C square plus 2BC, and BC and AD is equal. We squared because of the motivation given in the expression. So finally we are left with B square plus C square into X plus B square Y plus C square equals 0. And which gives me b square into y plus x plus c square into x plus 1 equals 0. And this is family of line in the form of b square L1 plus c square L2 equals 0. And definitely for all value of b and c, this will always pass through the point of intersection of x plus 1 equals 0 and y plus x equals 0. So answer is -1 and 1. Plugging the value, we get 0 as the answer for our first problem. Let's move to the second question. So here is the second question. The circle is inscribed in a triangle and 2 of its sides along the coordinate axis. So this rough diagram is going to be this. Locus of circumcenter of the triangle edge. Now we know, since circle is already fixed, so this line will keep on changing. The center of circle is 2, 2. Clearly the circumcenter of OAB is going to be midpoint of the hypotenuse. Angle O is 90. So let it be H, K. Since it's H, K, so OA length is going to be 2H and 2K by midpoint. And hence the equation of the line hypotenuse is x by 2H plus y by 2K equals 1. Now distance of 2, 2 from this line equals radius of the circle, which is 2 over here. So hence that gives me 2 by 2H plus 2 by 2K minus 1 mod by this expression evaluates to mod h plus k minus hk equals root over h square plus k square, which finally gives in terms of x, y plus minus root over x square plus y square equal to 0. So the value of k that we are getting is plus minus 1, k is positive, so 1 is the answer. Let's move to the third problem. And here we go with the third problem. Let p cube is the variable normal chord to the parabola y square equals 4x, whose focus is S, it's clearly 1, 0, with the centroid of the triangle SPQ. So PQ is variable. Normal chord. P, let's say this is normal line. Now centroid of the triangle PQS lies on this curve. Then we need to find GKW. Now this is again an interesting question. So if I'll take 2 parameter, let's say this point P with T1. So we know the point Q is given by T2 equals minus T1 minus 2 by T1. So T1 means 80 square 280 and Q is 82 square 282. So with this information, and let's say centroid of the triangle VH, K. Now what we can do is we can simply use the centroid formula, and what we get is 3H equals T1 square plus T2 square plus 1, and 3K equals 2 times T1 plus T2 because focus is 1 comma 0, so both. Now we have a relation between t1 and t2. So t2 plus t1 equals minus 2 by t1 from this expression. Eliminating t1 and t2, we get 3k by 2 equals minus 2 by t1, implies t1 equals minus 4 by 3k. Plugging this value in this expression, we get t2 equals 3k by 2 plus 4 by 3k. Now if I substitute t1 and t2 in this equation, what we get is 3h equals 32 by 9k square plus 9k square by 4 plus 5. And this is a locus representing this in xy term. 3x minus 5, 36y square is 128 plus 81 by 4. Rest is just comparison. So value of g that we got is 36, k is 81, and w is 128. And if we add and divide gk plus w, it's going to be 245. It's 245 by 49 with n. Let's move to the next question. If the area of quadrilateral formed by the common tangents to circle in the ellipse is given a, then we need to find value. So circle is x square plus y square 24. Ellipse is having parameters 6 and 4. So here I will solve it. So we know clearly circle is this guy. And we have an ellipse. Parameter 6, 4. Now the area of quadrilateral formed by their common tangent, because of the symmetricity, I can find area in one quadrant and I will multiply by 4. So we know the equation of tangents to the ellipse is root over a square m square plus b square. Now this tangent must have a distance of 5 from the radius of the circle constant. So 5 is going to be plus minus root 36 m square plus 16 by root over 1 plus m square, and that gives the value of m square to be 9 by 11, implies the equation of line is plus minus 3 by root 11x plus minus root 105 by 11. So the point where the tangent intersects is root 500 by 3 comma 0, and this is going to be 0 comma root 500 by 11. Hence the area is 4 times half into base root 500 by root 11 into root 500 by 3. So that is going to be 1000 by 3 root 11. The next interesting problem, and we can clearly see point P can be decoded as 2 into 2 tan alpha by 2 by 1 minus tan alpha by 2. So that's nothing but 2 tan alpha, and it is 1 by cos, so secant alpha. Similarly, point Q is 2 tan beta and secant beta. So locus of midpoint of PQ. As we know, this point P and Q is gonna be lying on the curve. If I call this as x and y, so we have y square minus x square by 4 equals 1, because secant is cot theta minus tan is cot theta equals 1. Clearly theta should not be odd multiple of pi by 2. So those points have left. Now we can consider the midpoint, since this is an hyperbola. So I can consider the midpoint of PQ to be, let's say, some h comma k. So the equation of PQ is going to be t equals s1. So that gives me 4yk minus xh minus 4k square plus h square equal to 0. Now we know if this substance, if this chord substance, so we have some situations like this. If a chord substance 90 degree at origin, so I'll homogenize this second degree equation, which is this hyperbola, with this chord, and we'll make coefficient of x square plus y square equals 0. So doing so, let's homogenize. So we have 4yk minus xh by 4k square minus h square equals 1. So now I'll write hyperbola in a cool way. We'll write 4y square minus x square equals 4 into 1 square. The reason behind is whatever curve it is, this expression will definitely pass through 0, 0. And it is second degree homogeneous equation. So it's like something x square plus something xy plus something y square equals 0. So this must represent pair of a straight line. Now which pair? Whether it's line pair like here, here, or it's exactly this. Of course it has to be this, because the point, let's say P, lies on both hyperbola as well as on this line. So P must satisfy this equation. So is the point Q. So now whatever this curve represents must be passing through P and Q, and also origin. So still we have many choice. We can have curve like this. Okay, we can have curve like circle or anything. But since we know it's a second degree homogeneous system, so it must represent pair of a straight line. Now the only way in which we have pair of a straight line, if it is passing through point P also, Q also, and O also, in just these two pairs. Now some of you might define why not it is going to be this pair. Let's say OP and PQ. Of course this will not be, because it must be pair of lines passing through origin. So the second line should also pass through origin. Okay. Now once we homogenize this, the direct consequence of this will be now coefficient of x square plus coefficient of y square must be 0, and that gives me 3 times 4k square minus h square whole square equals 4 times 16k square plus h square plus x square. I hope you have enjoyed the problem solving. I have tried my best not to kill your time. So it's a quick problem solving.